Hi, welcome to CCNA in 60 days. If you haven't already, please subscribe to the channel and hit the bell so you see all the other videos. Got a lot of stuff coming out for IT, certifications and careers. So we're doing WAN, including PPP, which could well come up in the exam, and we're on day 37. As always, read the cram guide, watch yesterday's videos. Obviously yesterday was end of module review, but you can review videos. Do the labs, take the online exam. The link is on day 0 and day 1. Do subnetting.org or 101 Labs IP subnetting. So today we're looking at WAN, PPP and some labs, covering some of the stuff that's in the theory, and also I don't think I do cover in the theory like PPPoE or PPP Fallback. There's definitely labs on that, if not labs in theory. Some books will help you. IP Subnetting 101 Labs, Zero to Guru book on Amazon, and also the 101 Labs Cisco CCNA version 4 on Amazon. So that's all for today. I will see you tomorrow.
Wide area networks. Basic knowledge of this is required for the CCNA exam, so I'm just going to go through kind of the main points you need to know. But here's a network representation with a diagram of your router on the far left. This is a data terminal equipment. This is what you're in charge of, unless you've got somebody contractually looking after your kit or you've rented it off your telco provider, which sometimes happens. You're responsible for the data terminal equipment. The CPE is a customer premise equipment. So it really does depend on your setup, but and it depends on what part of the world you live in, and again which part of which country you live in as well, because things can change between states and territories. To convert the signal into a format that the telco likes in this particular setup, we've got a CSU, DSU, which is a channel service unit, data service unit, and this will convert the data into a way your router can understand, into a way that your ISP can understand, and then that's always passed off then through your internet connection or your lease line over to your telco. So the sort of variety of connection you have is a lease line. You normally pay for a connection that's on there on 24/7. It's available 24/7, and it can just be used by your company. A lot of companies now have moved away, mainly because of the cost, from having a connection such as ISDN, which is only available as and when you need it, and you just pay for the time that you use it, but it just tends to be very expensive. So with ADSL now and the ability to use the telephony network, and we see less of ISDN. Circuit switching, it's set up whenever required, and then the connection can be torn down again. And packet switching normally is a shared connection of some sort, so there's a 2 meg connection, but you can buy chunks of that connection and share with other companies. The common WAN protocols, or certainly what you need to know for this exam: PPP. Normally you'll use this to connect to non-Cisco equipment. So if you've got a Cisco router connecting to a non-Cisco router, you can't use Cisco's default protocol of HDLC, because that only works on Cisco kit. PPP is really robust. It'll work on DSL, circuit switched, asynchronous connections, that's where clocks differ. Synchronous connections is where they agree, and it also comes with its own authentication. Cisco's version of high-level data link control is a default encapsulation for all Cisco devices. Basically what you'll need is your equipment, data terminal equipment, and then that will connect off to the DCE, which is your ISP side of the connection. The DCE basically controls the speed of the line. Frame relay is another really common one. I say common, it is used in some places and it's still in the exam syllabus, although it's not as common as it used to be at all. So frame relays are packet switching technology. The connection can really only go up to 2 meg, and it does start off at 56k, which is obviously a very slow connection now. Each time you want to set up a connection from one part of your network or the network to another, a virtual circuit is set up. Once that connection is no longer required, then it's torn down, and so the bandwidth can be available to be used again. Now it doesn't come with its own security, so It was all stripped out from the original protocol X21 to make it a lot faster. You need to know how to configure a basic serial connection for the exam. All you really need is an IP address each side and a clock rate on one side. Again, you don't normally need to worry about the clock rate unless you're working for the ISP. For the Cisco exams though, they may ask you, how you type in the clock rate command. You don't need to enable HDLC on Cisco routers on serial connections because it's on there by default. So here's a basic configuration just to get your serial interface up and working. I've added a clock rate command only because you need to know it if you've got a DCE cable connected to your router, say on your home network for example. Very important command for troubleshooting is to show controllers serial and then the number of your serial interface, such as 0 or 0/0. If you have DCE cable plugged in, you must have a clock rate. And this is another classic way they catch you in the exams. This particular one's got a DTE cable, so you're fine. If it said a DCE cable though, you would need to have a clock rate on this interface. Welcome to the PPP lecture. So PPP, point-to-point protocol, in real wide use all over the internet, and certainly if you're using a DSL connection you'll be using PPP on your home routers to connect to your service provider. So internet friendly, supports data compression, built-in authentication which is really handy. There's network layer address negotiation and error detection. Now PPP can be used over a whole multitude of connection types, which is why it's been so popular for so long. High-speed serial interface there, synchronous and asynchronous. If you're going to do a map to the OSI, layer 3, IP, IPX and AppleTalk. Layer 2, we're going to cover NCP and LCP. These are sub-layers of PPP. Layer 1, ISDN, V35, and there's a V35 cable there. Okay, I mentioned two sub-layers before of PPP. So the role of NCP, if you get asked a question in the exam, is to establish network layer protocols. LCP establishes, authenticates and tests link quality. Now funnily enough, PPP actually encapsulates the datagrams over the link using HDLC. Configuring PPP, things are appearing in the wrong order here, but never mind. So router 1, config T, go to your interface and add your IP address and a clock rate, and all you type is encapsulation PPP. The same for the other router, IP address, encapsulation PPP and no shut. That's all you need to do to change the encapsulation type. Now if you want to add passwords, then that's another couple of commands which we can come to. So you've got two flavors of authentication with CHAP, and these are classic exam questions. One is Password Authentication Protocol, or PAP. This sends passwords in clear text, so it does give you password authentication, but the problem is if somebody's sniffing the connection, then they'll be able to see the password. CHAP, Challenge Handshake Authentication Protocol, it doesn't send the password, it sends a hashed value over the password and over the link. So it's important to remember that the password, even if someone intercepted the packet, it's not the password they would be sniffing, it would be a hashed value of the password. Configure PPP, this is a real simple incarnation of configuring it. On router 1 you'd have your IP addresses obviously in encapsulation PPP. You configure a username R2, which is the host name of router 2, and then you'd add a password. On router 1 you configure a username R1 and it must match exactly the host name of router 1. And here's the config here. Username R2, password Cisco. Both are case sensitive, and I guarantee it, I can't tell you how many students I've given this lab to, pretty much exactly as this, and they've sat there for ages insisting that they've configured everything correctly when they've basically mistyped the username or mistyped the password. And same on router 2, username R1, password Cisco, so you just change the username. The other command to put in is PPP authentication chap. If you do in PAP, obviously PAP, but I don't know anyone that would use password authentication protocol when you've got chap available. Troubleshooting, pretty straightforward. Show interface and then the interface number, and just make sure the encapsulation is correct. And nearly always, like 9 times out of 10, it's that common, the incorrect username or password, i.e. someone's put the wrong case or they put a space in or something like that. Welcome to the PPP Lab. Real simple configuration. You don't actually need to worry about the loopback addresses. I've just pulled up a topology, and you don't need to worry about the static route either. So all you need really is a router with a host name, router A, host name, router B, and a IP address between the two, and just make sure you can ping. If we go into router A, conf t, host name, and I'll configure router B's host name. Hostname router B. Oops. Try again. Username router B. Password Cisco. So interface serial 0/0/0. Default encapsulation is HDLC. So we need to change this. 3 choices, and the one we're looking for is PPP. At which point the link will probably go down, as you can see there. Router B. I'm going to debug some PPP. I'm going to debug PPP negotiation and debug PPP authentication. Conf t, username router A, password Cisco. And now I need to go into interface serial 0/0/0, encapsulation PPP. Oh, the other thing I didn't do, so anyway, I just want to go through this debug briefly. Establishing PPP, and you can see the LCP, which I mentioned in the presentation as well. The one thing I didn't add was PPP authentication chap. Go to router B. Debug PPP authentication. Interface serial 0/0/0. PPP authentication chap. So you can see you'd actually get better debugs from live equipment. But you can see a request is sent and then the line comes up. So if I go to exit, show IP or show interface, you should be able to see the encapsulation set as PPP. Now this is a debug from another lab I've done, but you get a better debug on live equipment. Authentication protocol chap. So I just want you to see that the authentication is taking place. An acknowledge, a request, response is sent, then it's going into forwarding and authenticating, and then success message, and then the connection is brought up. So a real basic PPP lab. If you're having problems, first thing, make sure you can ping from A to B. The second thing is make sure you've set the correct host name on each router, and then the username and password on each router, and then set PPP authentication chap, and it should work fine.
Just wanted to record a real quick lab covering something that's now in the CCNA exam, rightly or wrongly. It's PPP with a fallback. So what this is, it allows you to set a backup authentication type. So we're going to go through a normal PPP configuration as you would on the previous PPP lab, but we're just going to add a slight twist to the command. And as we see the configuration go through, it all becomes apparent, hopefully. So standard encapsulation for PPP, you can see I've got a username R2, which the router will use when it's challenged, and the password Cisco with a capital C. PPP authentication. On router 1, I've configured PPP authentication chap. Connected to router 2 on the right. Obviously I've got them both connected on a serial interface. I'm using my version of GNS3 here, and it's a 172.16.1.2 network. Encapsulation again, PPP. PPP authentication. You can see the choices we have here. If I type chap and then question mark, and it shows I can fall back to PAP if I so wish. So I'm going to add the PAP command in here. So this is our PPP fallback configuration. Pretty simple. No shutdown. Obviously I forgot to put the username in, so I need to add that for the whole thing to work. Username R1, password Cisco. I'm going to add a debug PPP authentication on router 1. I've got to no shut the interface now. I left it closed so we can see the authentication all happening. No shut it, and you can see very quickly there's a challenge response, and chap has successfully been configured. It works exactly the same as if we'd actually had just the main chap command on, but obviously I just want to show you how the fallback command works, and you can see the encapsulation on the serial interface. Welcome to our PPPoE Lab. I've set up something simple in GNS3 with 2 routers connected via fast Ethernet interfaces. I wouldn't worry too much about learning how to configure this, but I just wanted to go through it because it's covered in the syllabus, but it's an implementation task and they're not asking you to configure it. Router on our left is going to be our ISP router. First thing we're going to do is create our BBA group, broadband aggregation. This will handle the incoming PPPoE connection attempts, which will come from our host on the right. So I'll give the group a name. Then what we need to do is bind the group to a virtual template. Next, we create the virtual template for the interface that's facing the customer. So when the client tries to connect and initiate a session, the router automatically creates a virtual interface to represent a point-to-point connection. We need to configure a virtual template and two items on our virtual template, which is an IP address and a pool of IP addresses. Now, one of the addresses from the pool will be allocated to the client when it initiates a session. You'll recognize the pool configuration if you've done the NAT labs. Now we're creating a pool of addresses from 192.168.1.2 up to 100. Last thing we need to do is enable our PPPoE group on the interface facing these customers' network. Right, so you can see the configuration. Broadband aggregation group is created in the virtual template. Apply to an interface, and you can see our pool also. Next thing we need to do is configure the client so it can initiate a session. On the client, we need to create the PPPoE dialer interface. The IP address will be negotiated. So that means the IP address is going to be provided to us. You want the MTU to be lower than the default Ethernet MTU, which is 1500, so I've just set it lower. And then we'll assign our the ISP facing interface to the newly created dial group. Now you can see the interface come up, and then next, any second, you'll see the dialer group come up. So the virtual interface is bound to the profile, as you can see on the output here. Virtual interface changed to up. Show IP interface brief, and your dialer interface is up. IP address has been negotiated. Show PPPoE session, and you can see our session is active. And then lastly, show PPPoE summary.